This is Ham College, episode 92, for August 31st, 2022. This episode of Ham College is brought to you by Icom. Keep your competitive contesting edge with Icom. Good evening, everyone. Welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And we've got some questions tonight that are going to be a little different than last week.
Just go ahead and say it.
They're not that tough, but
some of them are.
Unless you can't remember the answer.
Or you never knew it.
Or you never knew it. Yep, that works or doesn't work too.
Of course, I hope you're going to, when you go take your test, you're not going to do like me and come here without studying.
Yeah, true. Well, just to mention a couple of things. I am wearing a Hamvention t-shirt here, but it actually should say Huntsville Hamfest on it because I was just there and you were just there and Emil and a lot of our friends. Chip.
Yeah. Several people from the Soundcheck Net were there.
Yep.
A lot of people. Several of the contest winners were there from previous anniversary contests.
Yeah.
Yeah.
So
a lot of good friends there.
What did we talk about last month?
I don't know because I did not print my cheat sheet.
Well,
but I know what we're going to talk about this month.
I can tell you what we talked about last month.
Okay.
We talked about electro-optical technology, photoconductivity, photovoltaic devices, optical sensors and encoders, and optical isolators. So that was it, and it really...
It was a fun time.
It was a fun time. We knew a lot of the answers on that already, and good review on some of it as well. What are we going to talk about this month?
Well, it just so happens that I have the answer to that right here. We're going to be talking about digital circuits, digital circuit principles and logic circuits, classes of logic elements, positive and negative logic, frequency dividers, and truth tables.
Okay.
That's a lot to cover in a shorter period of time.
That ought to keep us busy for a while.
It should.
Which circuit is bistable? Is it A, an AND gate?
B, an OR gate?
C, a flip-flop?
Or D, a bipolar amplifier? Bistable. Well, I don't think it's an AND gate or an OR gate. Those are logic devices. I think it's going to be a flip-flop. I don't know what a bipolar amplifier is. I think it's going to be a flip-flop just based on the wording. Bistable. That's a guess, though. I really don't know.
Well, the chat room is all saying it is C.
Well, I'm sure it's not A or B.
No, I agree with you.
And I don't know what D is, so.
It's a flip-flop. Maybe a little definition on what bistable means
that would be nice.
Would shed a little light on the subject.
Be timely also.
Something that's bistable can be resting in either of two states. And I guess with a name like bi, that I could tell you that. An example of a mechanical device that would be bistable is a light switch. The switch lever can either be set to on or off, but not between. So, biostability is widely used in digital electronic devices to store binary data. It's the essential characteristic of a flip-flop, a circuit which is a fundamental building block of computers and some types of semiconductor memory. A biostable device can store one bit of binary data, with one state representing 0 and the other state representing 1. It can also be used for relaxation oscillators, multivibrators, and Schmitt triggers. So,
The old Schmitt triggers.
the old Schmitt trigger.
Hmm.
You didn't see that one coming, did
I
you?
did not see that coming. It just caught me blindsided.
All right. Well, let's move on to the next one here.
Okay. What's the function of a decade counter? A. It produces one output pulse for every 10 input pulses.
B. It decodes a decimal number for display on a 7-segment LED display.
C. It produces 10 output pulses for every input pulse.
Or D. It decodes a binary number for display on a 7-segment LED display. What's the function of a decade counter? They can be used for more things than just drive in a 7-segment LED display. So I'm going to rule out B and D. C. It produces 10 output pulses for every input pulse. That wouldn't be a counter. That would be some kind of multiplier. Yeah. So I'm going to say it's A. It produces one output pulse for every 10 input pulses. What do you think?
Yep, you're right. This is actually maybe the only one tonight I actually knew the answer for. I remember this one from when I took my test. It's
Oh,
been
really?
there for years. I remember it.
Huh. Everybody in the chat room is saying it's A. And it is.
Mm-hmm.
Which of the following can divide the frequency of a pulse train by 2? A. An XOR gate.
B. A flip-flop.
C. An OR gate.
Or D. A multiplexer. Divide by... Which of the following can divide the frequency of a pulse train by 2? Okay, it's not going to be A or C. I think again, I'm pretty sure again this is flip-flop. I'm pretty sure it's going to be B. Multiplexer. I don't think so. I'm not sure exactly what a multiplexer is, but I feel pretty confident it's a B.
So you're
Is the
kind of
answer.
flip-flopping on the answer.
No, I'm pretty sure it's a B.
Okay. That's what the chat room's saying. Flip-flop. Here, let me give you one of those.
Okay. How many flip-flops are required to divide a signal frequency by 4? A, 1.
B, 2.
C, 4.
Or D, 8. How many flip-flops are required to divide a signal frequency by 4? Well, since a flip-flop's only got 2 states, 2 times 2 is 4, so yeah, I'm going to say it is B.
Number B.
And that's what the chat room is saying. They're all saying B, so. And it is.
All right, I'll give you that.
Okay.
You earned that one.
Yeah. You know, this might be a good opportunity to take a moment and just explain what a flip-flop is, although everybody appears to know it already. This is a simulation of a flip-flop using 2 transistors. Now, normally today, you know, flip-flop's going to be an integrated circuit, but for descriptive purposes, this helps show it a little bit easier. Q1 on the left there, I don't know if you can see those yellow arrows. they are showing current flow. The current is flowing through R1 and it's going all the way through Q1 here. These two resistors, R1 and R2, in this example, it'd typically be 1K ohm resistors. R3 and R4 here would be 10K ohm resistors. You're conducting current through the transistor when it's switched on. When it switches off, you won't be drawing current that way. Let's look at the example. It's telling us to press the green button. Okay, that would be this switch right here, a momentary push button. Let's just look at it. If I do that, it's going to short out the signal on the base to ground.
Mm-hmm.
Right now, there's a little positive voltage that goes through R2, 1K, and on through R4, 10K, and it's on the base of this transistor, keeping it switched on. If I short that to ground, that's going to stop the conduction. Let's do that and see what happens. Now the current is flowing over here. What happened when I shorted this to ground? It stopped the flow of current there. So the current path coming through R2 and R4 over to the base of this transistor was interrupted. However, there was current flowing from R1 to R3 onto Q2 right here, switching Q2 on. That transistor switched on. The other one switched off because we shorted it to ground. So the voltage couldn't flow there. If we flip this switch, put it to ground, this one lost its positive voltage and so no longer conducting. And the other circuit picked right up and is conducting now. So they just flip and flop back and forth between each other. Now there's a lot of different variations and different types of flip-flop circuits out there. So I'm not going to try to name all of those because there's just too many. But, you know, common types might be, well, a JK flip-flop is pretty popular as well. You look like you got something on your mind.
No, I was just thinking about it. Plus, I also was trying to decide. I brought a couple of flip-flops too, but I'm not going to put them on the table.
Okay.
And demonstrate them this evening.
We all appreciate that. Which of the following is a circuit that continuously alternates between two states without an external clock? Is it A, a monostable multivibrator?
B, a JK flip-flop?
C, a T flip-flop?
Or D, a stable multivibrator? I don't know what a JK and a T, the difference between them. I don't know the answer for this for sure, and I'm not going to look at the chat. I'm going to guess it's going to be A. I don't know. I'm just guessing it's A. I don't know what a JK flip-flop is or the difference between that and a T flip-flop. Monostable.
Well, let's see.
Okay.
Did you hear that?
Yeah, I heard it.
Okay.
I told you there were going to be some buzzer action tonight.
Well, there it is, and this is kind of a...
If I'd have looked on there, I'd have got it.
Well,
but that would have been cheating.
they all got it.
The ones that answered got it. I know there aren't as many answered this time.
Oh, no. No. And it's a little harder, even if you knew this at one point but hadn't thought about it in 30 or 40 years, you might miss it.
Yeah, been probably close to 20 since I did the test.
So maybe a little explanation would be appropriate.
That would be very appropriate, and again, quite timely.
Well, let's first talk about what a multivibrator is. It's an electronic circuit used to implement a variety of simple two-state devices, such as a relaxation oscillator, timers, and flip-flops. There are three types of multivibrators. There's an astable multivibrator, which was the answer on this question. The circuit is not stable in either state. It continuously switches from one state to the other. It functions as a relaxation oscillator. So, yeah, that kind of sums it up. It's continuously alternating between two states with no clock. Astable. Monostable means that one of the states is stable, but the other state is unstable or transient. A trigger pulse causes the circuit to enter the unstable state. After entering the unstable state, the circuit will return to the stable state after a set time. Such a circuit is useful for creating a timing period of a fixed duration in response to some external event. The circuit is also known as a one-shot. There's a third type. There wasn't even an option here.
That was sneaky.
There's a bistable multivibrator. And in that case, the circuit is stable in either state. It can be flipped from one state to the other by an external trigger pulse. This circuit is known as a flip-flop. It can store one bit of information and is widely used in digital logic and computer memory. So,
very interesting.
3 types of multivibrators.
What is a characteristic of a monostable multivibrator? A, it switches momentarily to the opposite binary state and then returns to its original state after a set time.
B, it produces a continuous square wave oscillating between 1 and 0.
C, it stores one bit of data in either a 0 or 1 state.
Or D, it maintains a constant output voltage regardless of variations in the input voltage. You know, that don't sound like any of the stuff I just read.
It really don't.
What is a characteristic of a monostable multivibrator? Well, I'm going to start at the bottom. D, it maintains a constant output voltage regardless of variations in the input voltage. So I'm going to throw that out. I don't think that's it. C, it stores one bit of data in either a 0 or 1 state. I don't know. I'm going to hold off on saying what I think about that one. B, it produces a continuous square wave oscillating between 1 and 0. No. That would not be monostable. Or A, it switches momentarily to the opposite state and then returns to the original state after a set time. No, that's not monostable. So I'm going to say it is C. It stores one bit of data in either a 0 or 1 state.
Because it's mono.
Okay. Let's see, the chat room.
Maybe.
Oh, they're a little mixed on it. None of them said the answer I did, so I don't know where. This is
Will there be buzzer?
Will there be buzzer? I don't know.
Bring on the buzzer.
There is buzzer. Well, hey, I don't get a fist bump for that.
Yeah, you do, because I'm not the only one in the club.
Wow. It switches momentarily to the opposite binary state and then returns to the original state after a set time. I got to look at what I just explained here and didn't really catch. After entering the stable state, the circuit will return, or the unstable state, the circuit will return to the stable state after a set time. I wasn't even listening to myself. There was the answer right there. And the winner is, Spike got it right.
Congrats, Spike.
Arnie Arnie said what I said, that it was C. And Arnie, you and I both had the same wrong answer. So
Well, at least
you're
in
not
good
alone.
company. That's okay. I probably would have had the wrong answer too if I would have guessed one.
Yep.
Because it would have been a guess for sure.
Well, and that's kind of what mine was. For some reason, I wasn't thinking about it right, which has never happened before. Might I point
Well,
out?
it's the first time for everything.
Well, what do you say we take a break, get a message from Icom, come right back and talk about something that, an announcement we want to make.
Okay.
Keep your competitive contesting edge with Icom. Icom's high-powered base stations cut through pileups, letting you work the bands and record those contacts. Contest from the comfort of your home or remotely with the RSBA One app. Heard it, worked it, logged it. The IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. This innovative HF transceiver digitizes RF before various receiver stages, reducing inherent noise in different IF stages. The IC7300 changed the way entry-level HF is designed. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The real HF fun starts here. Create your own band opening with the IC9700. This transceiver brings direct sampling to the UHF-VHF weak signal world. This all-mode transceiver is loaded with innovative features that are sure to keep you busy. Faster processors, higher input gain, higher display resolution, and a cleaner signal. 4.3-inch color touchscreen TFT LCD, real-time high-speed spectrum scope, and waterfall display. Smooth satellite operation with 99 satellite channels, dual watch operation, and full duplex operation in satellite mode. Icom's IC7610 is the SDR every ham wants. This high-performance SDR can pick out faint signals in the presence of stronger adjacent signals. The Icom 7610 is a direct sampling, software-defined radio that has changed the world's definition of an SDR transceiver. RF direct sampling system, 110 RMDR, independent dual receiver, dual digicell. Icom's IC7851 gives you a new window into the RF world and is HF excellence unparalleled. With faster processors, higher input gain, higher display resolution, and a cleaner signal, it's truly the pinnacle of HF perfection. Dual receivers, digital IF filters, memory keyer, digital voice recorder, high-resolution spectrum waterfall display, enhanced PC connectivity, and SD memory card slot. Learn more about all these great Icom radios at icomamerica.com/amateur.
And thanks, Icom, for sponsoring Amateur Logic and Ham College. And speaking of that, Amateur Logic is coming up on its 17th anniversary. That will be in October.
It will. It don't seem like that. I know I say that all the time, but it just doesn't. I remember coming over here that very first night, doing the very first one.
I remember when we were shooting parts of it, and, well, it was right about the time of Hurricane Katrina, like the day before, I think.
Mm-hmm.
The day before it hit.
Oh, yeah. Outside.
Yep.
Yeah, I remember very well.
Jim out there with us showing us his WISP. Is that what it was called? Wireless ISP site?
I guess so.
Yeah. That's back before there was a lot of high-speed internet, which at that time was DSL for most folks.
Yeah.
So,
But that wireless ISP stuff, that was a big deal back then because not too many people had access to DSL.
yeah. Well,
They were just kind of putting it in.
There was a whole neighborhood there that a fair size one that site was at, and it provided service to. So, right after that, though, Bell South put in internet or DSL of those, so kind of shut that down. But I think they had some other areas too. But just eventually it got to where he couldn't make. Well, he was losing money with it, I think. So they had to shut him down. Anyway.
Marty says, what made you do a video podcast for amateur radio, George?
It
really didn't have nothing else to do.
Well, it really wasn't necessarily on amateur radio. I mean, it was just, we were just going to get together, and AmateurLogic didn't really mean anything with ham radio. It just meant not professional logic.
Just kind of coincidence that we're hams doing it.
Yeah, kind of coincidence that we were all hams. And it just kind of worked out that way that we mentioned ham radio, and hey, there were ham radio operators out there who saw it and liked it. And hey, we could talk about a lot of ham stuff, so natural fit. And that's kind of the way it went. But anyway, it's been a fun 17-year ride.
It has. It's still fun.
Yeah. And, we've got a couple of great sponsors in Icom and MFJ. And the last few years, we have held a contest every year on the anniversary of AmateurLogic. And that'll be in October. We're going to be giving away a prize package. It's going to have a radio, it's going to have an antenna, a power supply, and of course some coax to hook things together. And we'll talk a little more about that here toward the end of the show. Yeah, we'll get through these questions first, and then we'll have a little time to talk about that and see what's going to be given away this year. And we just got the contest stuff together pretty much right before the show.
15 minutes ago?
Yeah, so we don't have all the details yet. And we're going to kind of, this will be a preliminary of what it's going to be. And we're not actually going to be taking entries yet, but we will be taking them very soon. It's been a tough week. Basically, it has rained here almost every day. There's a lot of flooding in the area. And our websites were down for at least 24 hours.
Oh, yeah.
So we weren't able to get the contest website set up or any of that. It just came back a little while before the show tonight. So they're migrating our servers. So there really wasn't anything we could do about it.
Yeah,
We didn't have any.
It also took Roku down. So if you didn't get the Roku stuff didn't work earlier,
Yeah.
or Amazon Fire Stick or Amazon TV.
Yeah.
That's why.
Yeah. But the YouTube was still there because that's hosted on YouTube. We just upload the videos there. Anyway, we didn't have any advanced warning, so it just happened. And now it's back, and hopefully they have completed the migration and all will be well there. But we'll be announcing at the end of the show what we're giving away this year. Speaking of giving away stuff, we could give away something right now.
Well, how about one of these shirts? Let's give away one of Ray's shirts.
One of Ray's shirts.
Nice Icom, good heavy t-shirt, ham crew t-shirt.
Yep.
You'll look just as good when you leave the ham fest as you did when you got there.
You would.
Yep. Nice shirt.
So, if someone wanted to win that, well, they could send an email and say, we didn't even know we were going to do this tonight because the website and mail server were down. So
yeah, till right before the show.
Yeah, so we didn't get to draw a winner until right before the show. You send an email to hamcollege@AmateurLogic.TV. We'll randomly pick one of the entries out of there. We do it each month, and we'll announce right here on the show who it's going to be. What are the qualifications?
Well, they're pretty strict. You got to meet the qualifications. You need a name and an email address. If you don't have those two, you disqualified. Anyway, that's all you need is a name and email address. So send your email to hamcollege at AmateurLogic.TV. You can put a note in there if you want to. We love to read them if you send them, but it's not required.
Yeah.
And we don't need sizes, anything else. We'll draw your someone's name at right before the next show, and Icom will get in touch with you about getting your prizes to you.
Yeah. Some months we don't know what the winner's going to say. Some months they don't really say anything, but maybe their name, because that's all that's required. Sometimes they stick a little note in there for us. This month's winner did, and it is Teresa in Tennessee. She says, I watch Ham College with my husband, learning and laughing. Really enjoy your show. I'm studying for my technician license. Hope to test soon. Would like to win the Icom swag. And guess what, Teresa?
Today's your day.
Won. Yeah.
Congratulations.
All right. So if you'd like to be next month's winner, just send an email to hamcollege at AmateurLogic.TV. We don't save the entries in between contests, and we don't reuse the entries or keep any kind of list of it. So you'll need to enter after each show to be eligible for the next drawing.
Yep, queue's clear, so send your entries now.
What is a truth table? A table of logic symbols that indicate a high logic state of an op-amp.
B, a diagram showing logic states when the digital device output is true.
C, a list of inputs and corresponding outputs for a digital device.
Or D, a table of logic symbols that indicates the logic states of an op-amp. Truth table. You and I went over this before. I think we may have mentioned this on the show at some point before too.
Well, yeah, I think maybe the general, either the tech or the general. We had this.
Okay, so let's see if I can remember back that far. A table of logic symbols that indicate the high logic states of an op-amp. I don't think that's it. Diagram showing logic states when the digital device output is true. I don't think that's it either. List of inputs and corresponding outputs for digital device. Or D, table of logic symbols indicates the logic states of an op-amp. It's not A and D. I think the answer is going to be C, Charlie. A list of inputs and corresponding outputs for a digital device.
Well, that's what everyone over in the chat room is saying.
Yeah, we've gone over that before. It's been a while back, but I do remember going over it.
I'm going to agree with you. It is C. Matter of fact, we actually have a truth table here.
Are you telling me the truth?
Judge for yourself. This is a truth table for a 2-input AND gate. And you can see they got the 2 inputs there labeled A and B. And you've got an output on there as well. And the truth table is below. And it shows us if both of the inputs are at a 0 or a low state, you got 0 out. If A is 0 and B is 1, you got 0. If A is 1, B is 0, you got 0. If A, and here's the key word, and B are both 1 or high, you've got a 1 or a high out.
What logical operation does a NAND gate perform? A, it produces logic 0 at its output only when all inputs are logic 0.
B, it produces logic 1 at its output only when all inputs are logic 1.
C, it produces logic 0 at its output if some but not all inputs are logic 1.
Or D, it produces logic 0 at its output only when all inputs are logic 1. Okay. What logical operation does a NAND gate perform? A, it produces logic 0 at its output only when all inputs are logic 0. Nah. B, it produces logic 1 at its output when all inputs are logic 1. Now that would be an AND gate. C, it produces logic 0 at its output if some, but not all of the inputs are logic 1. Nope. I'm going to say it is D. It produces logic 0 and its outputs only when all inputs are logic 1. That's because I happen to know that NAND means negative and. Everyone in the chat room is saying it's D as well. A not and. You could also call it a not and gate. Now that's probably the more accurate term, and that's what Tom is saying over in the chat room. By the way, good to see you at Huntsville this past weekend, Tom. And it is. It produces a logic 0 and its output only when all inputs are logic 1. And we happen to have the diagram and a truth table here for it.
Get out of here.
Yep, not and. So that means it's an and gate. So if both of the inputs are 1, it's not going to give you a 1, it's going to give you a 0. The little circle out there at the output of it indicates it's not. It's an AND gate, but it basically inverts whatever it would normally be on an AND gate. So 2 1s on the inputs give you a 0 on the output. Otherwise, the thing's always got a 1 on it. It's always high. What logical operation does an OR gate perform? A, it produces logic 1 at its output if any and all inputs are logic 1.
B, it produces logic 0 at its output if all inputs are logic 1.
C, it only produces logic 0 at its output when all inputs are logic 1.
Or D, it produces logic 1 at its output if all inputs are logic 0. Produces logic 1 at an output if any or all inputs are logic 1. Okay. B, it produces logic 0 its output if all are 1. That's basically what we just said previous question. It only produces logic 0 its output when all, no. The word all is the kicker there. It produces logic 1 its output if all, no. It's going to be A. Produces logic 1 at its output if any or all outputs are logic 1.
I and everyone else in the chat room agree with you. And it is. And you know, I was thinking.
Truth table?
Oh, and a truth table. Actually, we do have one.
Look at that.
And being that you're a computer programmer and I am too, this is not just for gates or for semiconductor devices. This is used in programming as well.
Just logic.
It's just logic. So I know that you know it. So you explain this one.
Well, it's or. So if it's one or the other one. So if both, and it's not an in or not negative or not or. So if both zeros are, both inputs are 0, the output's going to be 0. If the first one is 0 and the second one is 1, so that's an OR, then you're going to have a high on the output of 1. Same thing on the next one. 1 and the 0 is going to give you the same result of a 1. And both of them are going to give you a 1 as well.
All right. So
So
basically,
anything that's, I'm calling it high,
yeah.
but anything that's got the 1 is going to give you the positive output.
So if you got a 1 on either input or on all of them, you're going to get a high on the output.
Yep. What logical operation is performed by an exclusive NOR gate? A. It produces logic 0 at its output only if all inputs are logic 0.
B, it produces logic 1 at its output only if all inputs are logic 1.
C. It produces logic 0 at its output if only one input is logic 1.
D, it produces logic 0 at its output if only one input is logic 1. Okay. So,
Exclusive NOR.
yep.
That's a
So,
little trickier.
yeah, it's a little bit. And it's a double thing. It's not just an OR gate. There's a couple other things to think about with it. It's a NOR gate, so that means not or negative or, if you want to think about it that way. So you could say, okay, well, it'd just be, opposite of the way the OR gate worked, but it's not. It's exclusive. Either of the inputs is 1, you get a 0 out. If both of them are 1, that doesn't count. It's exclusive. Only one of the inputs can be high to get a low out. So that is going to be, let's see, C. It produces logic 0 at its output if only one input is logic 1. I'm going to say that's it right there. It is C.
Yep.
Chat room?
I concur.
They're all saying C. And it is. Here's the exclusive NOR gate we just talked about, looking at the truth table there. And the thing that tells you it's exclusive, on the OR gate, it's kind of got that arch on the input side of it. Well, there's that extra little line right there and that separation between them. That means it's exclusive. Circle on the output there, that's telling you it's not. If either one of the inputs is high, you get a low out. Any other condition, it's always high out. What type of logic defines 1 as a high voltage? Is it A, reverse logic,
B. Assertive logic,
C, negative logic,
or D. Positive logic? Well, what type of logic defines 1 as a high voltage? That would be positive logic, D.
You went straight for the kill on that
Right
one.
to the throat.
We haven't even had time to hear from the chat room on this one. Of course, due to the delay in streaming there. They are all saying D.
Yeah, do you remember back years ago? I think it was like one of the Microsoft languages. They defined, I think negative was 0 and positive was anything that wasn't 0. So it might have been a -1.
It was a -1. I think that was basic.
Yeah. That was a long time ago, man.
Yeah. Yeah, it was.
Then they kind of threw us off and changed it.
True is -1.
Yeah.
Wow.
Kind of broke a lot of stuff.
Yeah, it kind of did. And if you go back and try to edit some of that old code, yeah, you might have to think about that. Well, that is all the questions for tonight. Let's take a quick moment, get a couple of things set up here, or at least make an attempt to get them set up, and come right back and talk about that 17th anniversary contest.
Okay.
Around the 15th of each month, it's Amateur Radio's original and longest-running video podcast, AmateurLogic.TV, with hosts George Thomas, Tommy Martin, Emil Diodene, and Mike Morneau. Roughly, here's what I have. The bottom trace here is ground.
while the elements will jiggle some, they're actually not too bad. It's light.
After putting it together, I decided to test everything, so I ran in 12 volts, and I'm measuring the output here.
No, it's not too windy right now, Jim. It was yesterday.
We're in the antenna switching matrix. Any one of our 6 broadcast transmitters could be connected to any of the 22 antennas.
I personally am so thrilled that George got the special award. Well deserved, my friend. That's really cool.
What about the Super Bowl, Emil? Did you go to the Super Bowl, or were you at home operating that night?
Tuning my amplifier, and I lost power in the shack, and went outside. The house lost power. The whole neighborhood went out for about 30 minutes. I don't know what happened.
Wow. That explains a lot. Now we can take this and put it over inside our box. It's flush to the bottom. If we were to rotate, we can see that thing goes all the way through, so we'll have a hole in the bottom.
What ammunition do you use in there?
Actually, you can use black powder, you can use WD-40, you can use, anything combustible. You just have to use the right quantity, and we assume no responsibility for mishaps.
Here's what it looks like after I've got them all soldered together and heat shrinked up. Okay, let's give it a try and see how it worked out. So there you have it, the hula loop. No, you can't null out the dogs barking.
I have 2 thin film solar cells to run this. Looks like a little mini weather satellite, actually. And I'm using guitar string for the antennas.
I particularly like that last one there, $29.99. You can get a 50-foot garden hose extension cord combo.
Do not get cord wet. Now, most of these J-poles are built with metal elements or tubing. The reason I chose wire for this one is the length of this particular one. So I wanted to hang it from the tree so I can hoist it up there.
Yeah.
Go fishing.
We couldn't find the reel.
Yeah.
Is that what that is?
All right, Tommy, sing the theme song here.
AmateurLogic will be celebrating 17 years October the 15th. However, I just looked, and that show will be shot on October the 14th on a Friday.
Early bird.
You get it one day early.
Cool.
On that show, we're going to be giving away Tommy's radio.
No, we're not. We're going to be giving away one just like this one.
Just like that one. Okay. All right.
Yeah, but we're not giving away this one. I'm not letting that baby go, man.
Our 17th anniversary contest, sponsored by Icom and MFJ. We're giving away an Icom IC705 transceiver, an MFJ 4230 MVP power supply, an MFJ 2389 8-band vertical antenna. Of course, you're going to need to hook it up. 25 feet of MFJ RG8X coax. Tell us about that radio, Tommy.
This radio, no lie, if somebody like tied me up, I had to get down to one radio, this would be the one that I keep. Honestly, out of all the ones that I got, I love this thing. It's awesome. I used it for field day, made a good bit of contacts with it. It's QRP, but with the external power, it goes up to 10 watts on HF. Does basically all your HF bands, 2 meters, 70 centimeters, FM, D-Star. It's got the waterfall in there, as you can see. It's touch screen. Got DR mode. It's got great Wi-Fi capability built into it, and I've shown a little bit of that stuff on the AmateurLogic in the past. It's a really sweet radio. The little hand mic is awesome. Mm-hmm. It looks like a little speaker mic, and it is, but it's a good solid, solid feeling mic. Yeah. It's very substantial. It's a really nice little mic.
So you might call this an all-band multi-mode radio, which it kind of is, because it's HF 6 meters, 2 meters, and 440. D-Star, DV, single sideband CW, RIDI, AM and FM modes built in. It receives continuously from 30 megahertz through 144 megahertz band, and of course also 70 centimeter band. And you can also enjoy, and I didn't realize this, the FM broadcast band and the air band.
Mm-hmm.
It's got RF direct sampling system. The thing looks like IC7300, identical on the front there to me now.
Mm-hmm. It's very close.
It's direct sampling system, so it's not where they took an analog radio and kind of adapted it.
One thing I really like about it is the power management. The thing uses so little power. It's got a battery on the back, uses the same battery as the ID51, ID52 handy talkies. They also got a thicker one, a bigger one. But it's got a place to plug in an external battery, and like I got that little 8 amp battery that I use at field day. It runs all day long, never even makes a dent in it. It's amazing how little power it uses.
And we were talking about it before the show. You said you don't know how well that battery is charged up, and I said, well, I've got more batteries because I have an Icom handy talkie. It's the same battery.
Yeah, same battery.
So that's mighty convenient there. Real-time spectrum scope and waterfall display. Obviously, you can see that on the front. And you know, I would not even consider a new radio. I don't even know if they make radios without those anymore, but it is a must-have feature.
Mm-hmm.
Once you get used to using that, you won't go back.
Oh, yeah.
Yeah. It makes things so much better to find signals. Large touchscreen color display.
Got it. Check.
Got it. Compact and lightweight design.
Check. Yep, I'd say that's lightweight.
And you can run it from the BP272 lithium-ion battery pack, which also works with the Icom handy talkies, or 13.8 volt DC external power. You get 5 watts out with the built-in battery or internal battery. Get 10 watts out.
10 watts with an external battery.
Yep. Wow, so many things there. One touch FT8 mode preset. I didn't realize it had that.
Yeah, they added that. That was a nice addition they put in the firmware update.
So this is not the same as when it came out. They've added stuff to it as it's come along. Cool. I didn't realize this. I should have. Wireless LAN and Bluetooth technologies built in.
Mm-hmm.
What can you do with that?
You can connect to it. You can do data transfer or remote to it, and do digital modes over the Wi-Fi and stuff like that. And I need to set it up and do some segments on that. I haven't played with it much, but
Yep. Built-in GPS functions.
terminal mode. We did a segment on that.
We did, and it's a D-Star radio as well, and by having the GPS, it can do the near-me repeater function.
Mm-hmm.
So it can find repeaters in the area. All the D-Star functions. And there's also available an optional backpack. If you'd like to get that, I know Dean Martin.
Yeah, I've got mine.
You can see him going to class, and that's on his back right there. And there's an optional tuner, the AH705, available as well. Micro SD card slot.
Yep.
And micro USB connector.
Yeah, and the micro USB connector, you can actually power or charge the battery through it. You can't power the radio through it, but you can actually recharge that battery, so you don't have to have the the regular Icom wall wart with the coaxial connector. You can plug it up, charge it with like a cell phone type.
So this thing, to me, as an outsider, looks like that's a very portable 7300, except it's got VHF and UHF and D-Star in it as well. So I kind of agree with you. Only one radio.
This would be the one. I promise you that would be the only one that I had if I had to go down to one. It does everything.
Yeah.
And honestly, you think 10 watts isn't really enough, but I did field day with 10 watts. Did just fine.
Yeah, I'm going to say you did a lot better than I was thinking, because I was thinking before field day, well, you know, Tommy's not going to do much with 10 watts, and I'll be running 100. So, but no, you did much, much better than I thought you would. I didn't realize you could do that.
Yeah.
With that kind of power. We're going to need some stuff to go with that as well. An antenna. We've got one here thanks to MFJ.
Got a MFJ 2389 compact vertical 8-band antenna. Quarter wave on HF, 80 through 6 meters. Half wave at 2.15 dBi gain on 2 meters, and a 5/8 wave with 5.5 dB gain on 440 megahertz. SWR is 1.5 to 1 or less. It handles 200 watts PEP or on single sideband, 150 watts on 6 meters to 70 centimeters. Super lightweight, less than 6 pounds, and it's just 8.5 feet tall. This antenna lets you mount a restricted space environment such as attic or a balcony, so that's pretty nice. Radio system's all built in, so no fooling around with counterpoise wires, and it's got a SO239 connection on it.
They have used that antenna at field day down there in Slidell for the last several years. And from what I understand, email always says it's an outstanding performer.
Mm-hmm.
So, great antenna there. You're going to want a power supply as well. And for that, we've got the MFJ 4230 MVP compact switching power supply. You've seen them here before. Tommy even has one of these. It's a mighty light power supply. It adds a pair of power poles in this particular model here. 30 amp switching supply with all the popular features. You got your choice. You use the Anderson power poles on the rear. You can use a cable with banana plugs, or you can use wire terminals right there on the front. Front panel features the 5-way binding post. 25 amps continuous, 30 amp surge at 13.8 volts, selectable from 4 to 16 volts. I would say variable. There is an adjustment right there on the front. You can adjust the voltage. Gives you a wide range, so it's handy. I use mine for things on the bench from time to time where I need a variable power supply. You can choose 120 volts or 240 volts at 47 to 63 hertz, so you can take it anywhere in the U.S., Canada, and abroad. They've been trouble-free for us as well, and of course MFJ is going to throw in 25 foot of their RG8X cable with connectors on it. That's the MFJ 5825X. So that's what we got. We're giving it away this year on, well, I guess we need to talk more about the details here. And I don't have this in a graphic, so we're just going to have to talk about it here. The IC705 transceiver, MFJ 4230 MVP power supply, MFJ 2389 8-band vertical antenna, and 25 feet of coax. So to be qualified, what's the number one thing that qualifies you?
You must be a licensed U.S. or Canadian amateur operator with a U.S. or Canadian shipping address.
And there's only one entry per contestant. Sending more than one entry is going to disqualify you, so keep that in mind. Only enter once.
And the winner is responsible for any taxes incurred.
The winner agrees to the use of his or her call sign and name in promotional news items related to the contest.
Must not be an employee or affiliate of AmateurLogic, Icom, or MFJ Enterprise.
And how you enter? Well, you are going to send an email. Now, the entries aren't open yet, so don't send the email right now. We'll give you the date here in just a moment. It'll be send an email to contest 2022 at AmateurLogic.TV, and we only want your call sign in the subject line. Only put your call sign in the subject. That way we can sort through the entries easier. That is one of the requirements, so only your call sign. Don't put anything else in there. Include your name, call sign, class of license, and address in the email. email. In the email message. And let me say that again. Down in the body of the message, we want your name, call sign, class of license, and address. And we're not harvesting this information. We'll throw it out at the end of the contest. Submissions must be made between Monday, August the 29th, and Monday, October the 10th of 2022. Tell us about the winner selection.
Well, the contest winner will be selected by a random number from the entries received. The winner will be announced on the October 15th episode of AmateurLogic.TV, which I think we said earlier that'll be airing on the 14th.
If it's determined the winning entry does not meet the qualification requirements, another one will be chosen by the same method. And contest rules and information are going to be posted at AmateurLogic.TV/contests.
Pretty basic. Same old as every year.
That is the same as every year. Prizes vary a little bit every year.
It's a nice prize package this year.
Yep.
Well, it's always a nice prize package. I like that little antenna. I love my radio, but love that power supply. That's a nice little antenna. I'm maybe looking to put one of those up at the house.
It is a nice antenna, and it gives you all those bands, 8 bands, in a compact vertical.
Yeah, I could probably find a place to put that up there.
Especially those with restricted space. It'll give you a way to get on HF. Well, I think that's going to do it for this evening on Ham College. It has been, I won't say it's not the toughest
Oh, no.
that we've ever had. Although there were 2 buzzers tonight. You don't get that every episode, so consider yourself lucky. And us unlucky, maybe.
Yeah.
Or just not quite as smart as...
He's not as up on it.
Yeah, this time around. And join us at the end of next month for another Ham College. And around the 15th, and I don't know the date yet, let's see. September, it might be on the 16th of September. I don't know. We haven't announced the date we'll be shooting the next
It'll be the 9th or the 16th.
Yep, one of those 2.
As many videos as I've got to edit, I'm guessing the 16th, but we'll see.
I think 16th, because I'm planning on going out of town on the 9th. Thanks for being with us, everyone. All you guys over in the chat room. And Arnie puts a final message in there. Reminder to the host, truth is always in a table.
It is.
Or on it.
Or on it.
Yep.
I'm going to go home and see about that, too.
It's about time, yeah, isn't it?
Yeah.
Okay.
All right. Well, appreciate you guys joining us, and ladies, 73. And we'll see you soon.
7-3.